One of the routine tasks Multigo is used for by analysts and experts worldwide is infrastructure footprinting on an organization's network, also known as reconnaissance. So, footprint is the technique employed to gather information such as IP addresses regarding a specific network environment, usually with the purpose of revealing vulnerabilities, indicators of compromise, and hidden weak points, as well as improving upon the current network policies and detention rules. So, in this lecture, we will detail a network footprinting methodology while demonstrating how investigators can use Maltego to implement it. We will also show how user can significantly simplify and automate the network footprinting process with the use of Maltego machine. So, what is the methodology of Maltego's network footprinting? So, when footprinting a domain, the goal is to find as much as information about its underlying infrastructure as possible. However, when dealing with a large footprint, it can be quite difficult to know when you have found all publicly available information about the domain that are under investigation. To make a process little easier, we have to create a structured methodology that we follow when conducting a network footprint in Maltego. So, using Maltego, transform to map network infrastructure and perform network footprinting. So, Maltego has a number of transforms that pull infrastructure data easily from OSINT and third-party data sources for network footprinting, and while returning the query result, the transform also map out of the relationship between each of the data points and visualize the infrastructure in a graph. So, as you can see in here, the arrows are labeled with the Maltego that transform can be used to find such information. So, now we will talk about find a related top level domain. So, starting at the top of the model with the target domain, we see an arrow labeled as TLD expand pointing from a domain back to a domain. This step searches for a top level domain that belongs to the target organization, a step that allows analysts to grasp the overall or interconnected infrastructure, especially in an international organization. Top level domain refers to a last part of an URL, for example, like .com. In the domain, Maltego.com is the top level domain, and the Maltego desktop client to domain which transform returns all top level domain related to the target domain. For example, we run to domain to find other TLDs to transform on a linkedin.com domain. These transforms return at 101 domain entities, including linkedin.asia, .de, .io and more. Find DNS names related to the target domain. So, once the top level domains are enumerated, we want to find the DNS records from the DNS servers database. This includes obtaining the domain's MX record, NS records and many A records as possible. A mail exchanger record specifies the mail server responsible for accepting the email message on behalf of a domain name. NS records that the internet where go to and find the domain's IP address, and A record is used to point a logical domain name such as google.com to the IP addresses of a Google's hosting server, which is like something like 74.125 something. So, in Maltego there are 9 transforms for finding a DNS name related to a domain. You can find them in the transform set as DNS from domain, which is a part of standard transform hub item. Running as domain, transform set this domain by usually clicking the fast forward icon returns the result seen as the graph. Then the purpose of this demonstration, we limited the number of a result returned by a transform to 256. Note that there are 408 entities in the DNS name collection node, so indicating a large number of infrastructure with a wide attack surface. Taking a look at the data model again, we see that there are 3 transforms going from the DNS name level up to the TLD level. 2 of those transforms looks for domain that share the same name servers or mail servers that has found the original domain. The third transform simply extract the domain from the DNS name. Following the data model, we will resolve all the DNS names to IP addresses by selecting the DNS entities and running to IP address transform. It is interesting to note that there are 304 of the 408 DNS name resolved to a single IP address as shown as this image. On the remaining 104 DNS entries, 45 did not resolve to an IP address at all. This might be an indication of an old DNS or a DNS name that resolve an internal resource configured on a split DNS system. Now that we have an IP address, we can go look up the level and data model to find more DNS names that related to their IP address. This can be done by looking at a historical DNS record collection from a passive and reverse DNS data. Alternatively, you can use Maltigu's docking technique by querying Bing to see other websites that have been resolving to the same address. From the IP addresses, we next want to find the net blocks that the address belongs to and determine whether the entire net blocks belong to our target organization. So, net block refers to range of IP addresses that are owned and managed by internal service provider, which is mean ISPs or data centers. An IP net block provides details about the owners of the entire IP range as well as its administrative contract, organization and more. So, in Maltigo there are 3 transforms for finding net blocks from an IP address, and it is important to understand how each of them works. To net block, which is like transform, will sort IP addresses into net block size specific by the user. Note that it is important to configure the correct size of the net block to conduct the accurate investigation. So, another net block is using the route info. So, that transform determines the net block that an IP address belongs to by looking up and routing the table information, and last one is using WHOIS info, and this transform will look up to the net block for an IP address by querying the registers. Running the net blocks using WHOIS info transform on our network footprinting, demonstrating result in those images. As you can see, the images shows only portion of the resulting graph. So, at this point we have reached to the data model. The next detail would be take the as found that we start moving back up the data model, that we find more related information at each level. So, first we inquiry that we return all the net blocks found on the found in this, and these new net blocks will be found more DNS names by querying historical or reverse DNS record. To do this, we run 2 DNS name, which is like reverse DNS transform. From the new DNS name return, we could potentially find more domain belonging to the target and start the whole process again on the new domains. As our network footprint proceeds further, our graph also becomes more and more complicated. To easily identify the most common parts of the network as well as its outliner, we can select the ball size by link, which is like main incoming view of the left toolbar. So this view adjusts the size of each entity based on the number of incoming links. So that's all about basic overview of the Maltego. So as you guessed, it is kind of a complex, but it also gives you a lot more information. So, and fortunately it's not required to remember every step of the footprinting process, because Maltego has feature called machines. So Maltego machines allow you to skip transform together and have them run sequentially in a automated fashion. So you can also do this in the software itself, and that's for all.